So today we're back in the shed, gonna have another little go at this, what's it called? Fiorenzato Fenice, this Fenice espresso machine. So you've probably seen in episodes before, we've stripped off the bodywork. We have found that the wiring was a bit iffy, so we've sorted that out. That got us power. We got to the pump, that wasn't working, so we've replaced the pump. After we did that, we got water moving around the machine, but everything was coming out and into this, out of this drain here rather than into the boiler, so we're not filling up the boiler. So there's a problem there somewhere, so we're going to trace through and find that. I suspect it's something to do with the boiler fill solenoid, which is, where are you, this fella here. So water goes into an espresso machine, and the same water has to either go into the bit that brews the coffee or into the bit that makes the steam, and the solenoid valve there controls which direction that goes in, and I think that's not doing what it ought to. Either that, or there's just a blocked up pipe, blocked up with limescale or something like that. I'm pretty certain that the this is the autofill control box. I think, given the fact that the machine is low on water, and when you switch it on, the pump automatically fires up and tries to fill the boiler, is telling me that the autofill control box is working. But the water is actually being diverted to waste rather than into the boiler, so probably that solenoid. Or there's a funny, what's this fella here? I've not seen the like of this before, so we'll take a look at that and see whether that's something to do with it. So yeah, we've got some solenoids we can swap over. We'll have a look at it. So, some success. So just to explain again sort of what the problem was, and to the uninitiated, what this is a single boiler commercial espresso machine, also known as a heat exchanger machine. What it needs to do, it needs to be able to create water at a really high temperature to create pressurized steam, and it also needs to brew coffee at the correct temperature for brewing coffee. So if you were to try and brew coffee with the water that's the same temperature as is making steam, it would be dreadful. It would over extract the coffee really quickly because it's just too hot. It just dissolves too much out of the coffee really quickly, and it would just be bitter and thin and watery. So what it does is you've got the big copper cylinder here, and that is where your steam comes from for steaming your milk. And then within there, these are the tops and the outlets here of what we call the heat exchangers. It's basically like a kind of a boiler within the boiler. And when you want to brew your coffee, you hit the brewing switch, and it takes cold water, and the water comes in through the bottom of the boiler, passes through these heat exchangers, and it picks up water from the water in the copper cylinder, picks up temperature from the water in the copper cylinder on its way through, and then by the time it's passed through all the metalwork and into your coffee, it's kind of got to the right temperature for brewing coffee, kind of sort of between 92 and 95, something like that. How it does that is water comes right, now how can I do this nicely? So we've got water comes in from the mains, or in this case from a tank, and it comes into the pump. The motor spins the pump, and the water comes. Oh God, where does it come in? So it comes in. The actual mains hose is attached down here. Okay, right, we've got a little thing down here, and then it goes into some copper pipe work, and then it comes into the pump here, out of the pump, along this pipe into this little this kind of manifold thing here. So what we've got here is the boiler fill solenoid. So when you draw a shot, when you hit the shot button to make an espresso, that activates the pump. This remains closed, so water can't get past this bit, and what it does is it goes down this pipe here, and then it goes into the heat exchangers on its way to the group heads to make your coffee. When you want to fill the boiler up, what happens is the autofill system, there's a little probe there, that's the autofill probe in conjunction with the autofill control box here. It tells the system that the boiler's not got enough water in it, and it opens up this solenoid and activates the pump. So what happens is the water comes through, and it is allowed past there, and then that starts filling up the boiler. Okay, so this is where I thought the problem was. Right, so what happened was, I took all this manifold bit apart. So I sort of started by taking off the solenoid, and we had no flow coming out of this bit. This bit, it turns out, that was a bit of a mystery to me. It's just a mains pressure regulator. So if you've got really high water mains pressure coming in, it will step that down a bit, so as not to cause problems with the machine. And we were getting kind of a bit of a lackluster kind of flow coming through there. I took that off, and it was still kind of pulsing just out of this bit. So this is where the pump goes into the manifold. If we took all this off, take all this off, and then it's got no restriction to the water coming out, so it should be flowing really cleanly out of there. That was still just kind of glugging. So I took the inlet hose off of the manifold and just switched the machine on to run the pump, and that was glug, 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 and then suddenly it went nicely, started flowing really nicely. So all it was, we just had an airlock in the system because of the machine having been a bit empty and all of that. So put it all back together up to this point here, and then it ran really nicely. So then I put the solenoid back on, because I still had my doubts about it, without the outlet pipe here on it, so it could just flow straight out, could see what was happening, and that was fine. It all started flowing really nicely. So I put the whole thing back together again and turned it on, and the boiler started filling. So that's the result. So it's all, the boiler's filling up, it's watertight, except for this bit on it's put a bit of PTFE tape on this joint here, caused a little drip there, but that's no drama, which means that we can move on to the next bit. Good. More good news. So now we've got water into the machine, we could then see whether it actually heats up and whether the heating element works and all of that stuff. So yeah, we filled the machine up to the correct level and turn the switch on to position 2, which is the one which normally gets the element turned on. You've normally got position 1, which turns all the systems on except for the heating element. Position 2 turns everything on, including the heating element. Turn that on, nothing happened. So I was concerned about that switch. It's a bit of a wrong one, so I put it into position 1, and then it was all systems go. So yeah, there's something wrong with that. We'll sort that out. But those rotary espresso machine switches and wiring one of those from scratch is not something I'm relishing the prospect of. But anyway, for now, we've turned it on. We've got heat coming into the machine, so the heating element's working. We've got it up to temperature. We have pressure in the boiler. Woo, look at that. And then we've got steam, and nothing is leaking, it would appear. No, nothing's leaking. And so that means we can descale it. Yeah, happy days. What happens is descaling an espresso machine, if you've got a machine which is watertight, will hold pressure, is all operating safely, then you can just descale it with everything in situ, which is the easy way to do it. If you've got hold of a bit of a basket case of a machine, like most of the ones I've ever done up before, which are complete non-runners, won't hold water, no power going to them or anything, that's when you have to completely strip everything down, get all the boiler out, all the pipe work, absolutely everything that holds water, take it all out, separate it all, stick it in some big kind of tank with a load of citric acid. That doesn't work well because you're doing it in cold water. Citric acid only really works well when it's hot, which is why you want to do it in situ in the machine, so the machine can do the heating. It can just sit in there and descale everything. If you've got to do it in like a cold bath or stuff, it takes weeks. You've got probably about 10 hours of assembling and disassembling stuff. So yeah, this is good news. It means that we can just fill the thing with descaling stuff. So we'll do that next. All right, descaling then. Why are we doing this? Because the water, especially around here, has got loads of calcium in it, causes us all sorts of problems. It builds up on the heating element, means that that's got 3 times as much work to do. It builds up on all the surfaces on the inside of the boiler, again causing it for the heater to have to work harder because it kind of insulates it. Also, I've seen boilers before. I've took the end plate off the boiler and found that there's almost no space left for water. It gets all in the pipes. It clogs up pipes. It clogs up little waterways. It just makes a mess of your machine, and 99% of the time, machine failures are often down to lime scale. This machine, 2008 it was manufactured. I've got no provenance of how it's been maintained or looked after, so we're going to go through and we're going to descale the whole thing, and we're going to replace all the major components. So descaling, here we go. What are we going to do? So you want to get your inlet hose, disconnect that from the mains, and have a bucket. I've got about 10 litres of water in there. I've also now got this is a kilo of powdered citric acid. Get it off eBay. It's perfectly safe stuff. It's they use it in cooking, and I don't know what they do. I descale espresso machines with it. Right, so get your 10 litres of water and your kilo of citric acid. That's what this is. Give it a stir up. Try and get it as dissolved as you can, because we want to get all this into the machine. Okay, we've got the machine drained down already, so the machine is cold. We let the pressure out, and then this machine has got a drain off tap at the bottom of the boiler, which is always a classy move by espresso machine manufacturers, because so many don't do that, and it makes it a thorough pain. So if you want to do any maintenance on your machine, all right. So I've just stirred in that kilo of stuff into the thing. So now what we're going to do, that's going to go into the machine. That's right. So when the machine switches on, it will try and fill itself up using the autofill system, which we explained before. But we want it to fill high. So what it normally does is it normally fills up about 2/3 of the way up the cylinder to allow headspace for the steam. We don't want it to do that because we want the citric acid to maintain full contact with every surface of the cylinder, and also get into all the pipe work and everything else. So what we're going to do is this boiler fill level probe again. We're going to pull that off, and that's going to trick the machine into never realising that it's full, and that's going to allow the water to keep on filling up and up and up until we completely fill the thing up. So what we're going to do is we're going to open the steam taps here, and then what will happen is the machine will overfill to the point where it's coming all the way down the steam tap. Oh, there's something wrong with that one. It will overfill, and we'll get water coming out of the steam ones, which should never normally happen, but that will mean that we've got descaling solution in all the pipe work and everywhere. Good, right, so let's get this thing turned on and filling up. So we've got some descaling stuff into the machine now. So what's happened is we've overfilled the machine so that it was all coming out the steam ones and that. We've plugged it in so that the heating element keeps stuff hot. So that means that we should get this thing done in about 2 hours, something like that, I reckon. So yeah, we're just going to leave it to sit there ticking over. Little trick is I've turned the pressure stat down so it just maintains the boiler pressure at about 1 bar, maybe just under, because when it's full of water it starts playing havoc with the pressure gauge and the pressure stat. You can send water up into the pressure stat, which you don't want to do that. Good, and yeah, so here's some stuff that I've drawn off of the steam one sort of immediately, and that shit. Ugh, that's green stuff. That's what the descaling solution is broken down already. It's green because of the copper, but I mean that's all contaminated shit in the water that shouldn't be there. So it's doing its job. That's in a few seconds. So a couple of hours we'll get it all drained down again. We'll probably even crack the boiler end plate off and see what's happening. So yeah, cheers. Okay, so we're just draining the machine down now. It's been in there for a couple of hours, and you can see here as it comes out of this manky looking old drain fitting, you can hear the citric acid sizzling and fizzing away at the lime scale that's built up around that just on its way out. So when this is all drained down, I think what we'll do is we'll take off the boiler end plate. We can see around here all those bolts on there, so we can remove all those fittings, remove the wires from the heating element, remove the element itself, take all the fittings off, and then we can actually get in and see right inside. Fucking thing I've hit my head on. You can see right inside and move the see how we've done. You can get right inside and have a look, see how we've got on filling, descaling the boiler. It should be all nice and bright and shiny. Yeah, so that's mostly that. What else do we do then? Oh yeah, and then what we need to do is we need to fill the boiler up and drain it, fill it and drain it, fill it and drain it. So we've got rid of all the traces of citric acid that are in there. Unfortunately, when I was trying to fill the group heads up with descaling solution, they sent some water in some unexpected directions, and now every time I turn the machine on, the house goes dark. So we'll rectify that little thing. It's probably just a case of it to dry out, and then we'll be good. Yeah, let you know. Right, now then, so I've got the end plate off the boiler. That's this guy here. So this is a bit of the heating element going through. See all that green stuff on there? That's where there's been leaks in the past. So that's what told me that there's going to be a lot of limescale in here. But first thing I did was remove the heating element after the descaling, and look at that. Beautiful, that is a result. So we would have expected that to have been, you can see some residue just on that bit there. That would have been all completely caked on solid with limescale most likely. And then we take a look inside the boiler. Now these tubes here that you see, these are the heat exchangers I was on about before. That black mark there, that's kind of the water level that the water normally sits at. So yeah, it's looking, look at that, all nice and all clean. So prior to the descaling, that would have all been full of crusted on limescale. You can kind of see some crusty bits, and then in the water that hasn't drained out in the bottom, that's a lot of the limescale. There will have been a lot more than that, but that's all sort of loose and it's all been detached now by the citric acid. So what I'm going to do is we'll just kind of mop that out. And then we'll end up, and I'll give a bit of a scrub where we can see these kind of white residual bits of limescale, although that's just Yeah, we'll just give it all kind of, I'll get my hand in there and give it a good scrub. So that means that now we can replace the boiler gasket, which is always, if you're going this far with a machine teardown, then that's always pertinent to do. We can replace the pressure stat. This is what controls the pressure in the boiler. Normally we would replace the heating element at this point. So this machine is 20 years old. We've got no sign of when it might have been done previously, but the one I've been able to get hold of is not the correct one for this machine. It's for the restaurant version, the compact machine with a much smaller boiler. So this bit of kit here this is 3.5 kilowatt. The one I've been able to get is like 2,750. So it's going to reduce the power in the machine, which when you're in a busy cafe and you're serving like lots of Americanos, you draw a load of water off the boiler refills itself with cold water and then has to heat up again. It just takes ages to recover if you haven't got the adequate heating. So I think on this time I'm tempted, as we've descaled it and it's looking good and there's no sort of scorch marks and stuff on the terminals and all of that, I think we're going to replace, we're going to put that fella back in. I reckon it's looking pretty good. We know how to replace it anyway. It'll just be more difficult if it does fail when it's actually in service, but I don't think it will. Fingers crossed. All is well. Right, we'll do that, and I might put the other element in. I don't know. We'll see. Anyway, right, I've got the machine all buttoned back up again now after the descaling. Excuse my fingers. That's the worst of it done. Right, we've basically broken the back of it now, so it's all good. So in the next video we'll probably, what should we do? We shall we shall probably replace the pressure stat. We'll have a look at replacing the seals in the group head so that they flow nicely, and then we'll probably do a bit more descaling because I didn't get any into the heat exchanger on this side because it all went wrong and shorted out the electrics. We sorted that out. That was just this solenoid on it. Yeah, that's all good. So yeah, worst of it done. So a couple more jobs to do on the next video. Yeah, groups, probably taps, maybe look at some bodywork. We've made a start on that, so stuff going on there. Thanks for watching.